Hello and welcome to my quick presentation on some relationships between Calc 3 and my major, which is aerospace engineering. Today the class I'm going to be focusing on is how Calc 3 and statics work together. So this first problem is going to focus on vectors and dot product, which was a beginning chapter that was covered in Calc 3. So to begin by solving this problem, we have to look at each of these 3 points, A, B, and C. So we're going to create points for each of them. And we know that A, so this right here is the z-axis, this right here is the y, this right here is the x. So using this, we can use our coordinates. So we know that this one's going to be at 0, x, it's going to be at 0, y, and it's going to be at 6, z. Now our point B is going to be at 2 in the x, oops. It's going to be negative 3 in the y, and it's going to be 0 in the z. Now we're going to do the same thing for C. This is going to be 3 in the x, 2 in the y, and 0 in the z. So now using these points, we're going to create vectors for each of these lines for FB and for FC. So FB is A and AB, so it's that line right here. So we're going to create that vector. So to do that, what you have to do is subtract point B, which in our scenario is our final point, minus point A, which is our initial point. So subtract the x's from each other, so you get 2 minus 0, which is 2, negative 3 minus 0, which is negative 3, and 0 minus 6, which is negative 6. So there's our vector AB. Now for vector AC, we're going to do the exact same thing, subtract C from A. We're going to get 3, 2, negative 6. So now we have our two vectors. So in order to find the magnitude of the resultant force, we first need to figure out what the vector components of the force are for each of these. So in order to do so, it's the force, which is of each of these. So we have FB's force and FC's force right here. So in order to calculate the force of each of these, it's FB and then times our unit vector for AB. So I'm going to redraw this times UAB. And then the other one's going to be FC times the unit vector of AC. So we have these two. So we're going to create the unit vector, and the unit vector of this is, we have to calculate the magnitude of AB, which the magnitude of AB is going to be the square root of all the components squared and if you do all that, you end up coming out to 7. And if you do the same thing here for this one, it ends up coming out to the same as well. Now, to get a unit vector, what you do is you divide each of these components of the vectors, you divide it by the magnitude of the vector, which we end up getting here, which is 7 for both. So we can create UAB is equal to 2 over 7, negative 3 over 7, negative 6 over 7. And we have UAC is equal to 3 over 7, 2 over 7, and negative 6 over 7 as well. Now we can use these formulas right here, which is where we multiply the forces that were given by our unit vectors. So for AB, we have 589, which is our force for FB, which is the AB, which we have right there. So we have 589 times 2 over 7, negative 3 over 7, negative 6 over 7. So now we have that, and that ends up coming out to 168.29, negative 252.43, negative 504.86. And then we do the same thing for unit vector of AC, where we take our force C, which was 652, times our 3 over 7, times our 2 over 7, negative 6 over 7. And then we have that, and then we calculate, once again we multiply it out, we get 279.43, 186.29, and negative 558.86. So now we have our two force vectors. So this tells us the force in the x, the y, and the z for each of these. So x, y, and z. Now in order to calculate the resultant of this, we have to add them together. So we add the x components together, we add the y components together, and we add the z components together. So just kind of add these two vectors, and you end up getting 447.72, 66.14, negative 106.3.72. So this right here is our force resultant vector. However, now, if we want to calculate the magnitude of this, which is what the question was asking for, what the magnitude is, once we go, just like what we did before, we take the square root, ignore that part, of each of these squared. So 447.72 squared plus negative 66.14 squared plus negative 1063.72 squared. And just like that, this ends up coming out to 1155.99. And this right here is our final answer for our resultant force. And this is, of course, in terms of Newton, since that's what we were given. So that's how you go through this problem right here. And for the dot product, I want to show how you'd be able to find the angle between these two vectors. So let's label this angle right here, theta. Now we can use the identity over here that I'm going to label, let me draw it out. I'm going to label the black vector, the blue vector B, and the black vector A. So we can use the equation A dot B is equal to the magnitude of A times the magnitude of B cosine of theta. Now, since we know each of these, and we already did some calculations, we already have the magnitude of AB is this over here, and the magnitude of AC is this right here. So we already have those two. And we know each of them is 7. So all we have to do now is the dot product between A and B. Now the dot product is of these two vectors. So we have this vector right here dotted with this vector right here. Now in order to do the dot product, all you have to do is multiply the x by the x plus the y times the y plus the z times the z. So in doing that, we end up getting 2 times 3, which is 6. And then we have negative 3 times 2, which is negative 6. And negative 6 times negative 6 is plus 36. And those 6's are going to cancel. And we already know the magnitude of A is 7, and the magnitude of B is 7. So we have 49 over here. Cosine theta. And now all we have to do is divide both sides by 49, so we get 36 over 49 cosine theta. And in order to solve for theta, all you have to do is take the cosine inverse. So the cosine inverse of that ends up coming out to 42.79 degrees.